welcome again to our channel, Shifting Grades. As you continue watching us, kindly be subscribed. Just in the headlines on your right hand, you will see the word subscribe in bold red. Kindly just tap that button and you'll be subscribed to our channel. With that, you'll be receiving notifications immediately we upload a new lesson. So we are now continuing with the topic longitudes and latitudes, and in this session we are doing the relationship between longitudes and time. It is good to note that the Earth is spherical, and therefore now following one latitude, you realize that now if we follow this latitude, for example the equator, the whole globe, because it will be circular now, this circle called equator is circular, you will find that now it is 360 degrees. And therefore now, because we know that the Earth rotates around the sun, then it rotates for 24 hours, or what we call a complete day, which has 12 hours for night and 12 hours for the day. Therefore now, for the whole globe to go around the Earth's surface, because it is circular, we say that the 360 degrees rotates for 24 hours. It is good we know how many minutes are in the 24 hours, because you know 1 hour is 60 minutes, then 24 hours by 60 is 1,440 minutes. Therefore, a whole day has 1440 minutes. Therefore, now for the whole globe to rotate from one degree to another one until the 360 degrees globe has rotated, it takes 1440 minutes. Therefore, we can relate and get this comparison, which says that for the 360 degrees of the whole globe to rotate around the sun from a degree to another one until the 360 has rotated, it takes 1,440 minutes. So with that, now we can relate and say for the Earth to rotate 1 degree, then it takes divide by 360, and this gives us 4 minutes. Therefore, for the Earth to rotate from a longitude to another one, which are a degree far from one another, then we can say that for every 1 degree, the Earth takes 4 minutes to rotate. And with that now, we can use this comparison now to get the time for different places on different longitudes. Therefore, it is good to note that because the sun rises from the east, time in the east is ahead of the time in the west. Therefore, if this is the sphere of the Earth, once it is rotating in a west-east direction, therefore it rotates such a way that this west is going to the east. Therefore, you find now if a place is on the east, it gets light of the sun, or this place downs before the places on the west. Therefore, we find before it rotates and the places in the west can receive the light of the sun, then you find that the places which are far much in the east have already dawned. And that's why we are saying, now if we have the globe like this, then you find there is a longitude here. This is 0 degrees, the prime meridian. Then other longitudes like this. When and others on the west. So when this globe is rotating, you'll find that the places in the east receive light. If this is 170 degrees in the east, light or this place downs before maybe 110 east. So you find places on this longitude receive light before places on this longitude and before places on this longitude. Like that, you find later it is these places which will get downed. So it is very logical to argue that time in east is ahead of time in west. You find if this is 150 degrees west, the time here is far much behind compared to the time in the east. Therefore, places on the same longitude have the same time, because if a place is here and another one is here, the sphere of the earth is rotating like this. Because it is upright, you find all the places along a given longitude are dawning at the same time, unlike places which are on a different longitude which has not yet received the light. Therefore, we say that now places in the east are ahead in time compared to places in the west. Therefore, we can say to get time for places in the west, we subtract the time difference. Subtract the time difference like that, because time in the west is behind. But to get time for places in the east, we add time difference. We add time difference. Therefore, we first of all get the longitude difference, and because time in different longitudes is different, we compare now using this relationship that 1 degree is equals to 4 minutes. And after getting the time difference, now we compare where is the place. If it is in the east, then we know that time there is ahead and we add the time difference. If a place is in the west, then we will know that places in the west are behind in time and we will subtract. Let me give an example on this. You are told, find the local time in Nairobi. Find the local time in Nairobi, and Nairobi is 1 degree south and 37 degrees in the east. If the time in Mandera, if time in Mandera, which is 4 degrees in the north and 42 degrees in the east, is 3 p.m. like that. Therefore, the time in Nairobi and the time in Mandera are being compared. We can get the solution for that. It is advisable, and I'll always comment this, that whenever you get a question like this one, kindly sketch the position of the two places. So with a globe like this, 0 degrees equator and 0 degrees the prime meridian, you can say Nairobi is slightly below the equator because it is 1 degrees south, and 37 in the east. 37 degrees east. Therefore, this is Nairobi. 37 degrees in the east. Now, Mandera is 4 degrees in the north. 4 degrees in the north and 42 in the east. Therefore, 42 in the east. 42 east. Therefore, you find Mandera is here. Mandera is 42 in the east. Nairobi is 37 in the east. Therefore, when you compare these two places, then Mandera is much on the east side compared to Nairobi. Even though the two places are in the east side of the prime meridian, then Mandera is more to the east compared to Nairobi, meaning that time in Mandera, which is far much east compared to Nairobi, is ahead. Therefore, we are finding time in Nairobi and time in Mandera is given. Therefore, we can get first of all the difference in longitudes. And therefore, because Mandera is at 42 in the east and Nairobi at 37, then the longitude difference between the two, from 42 to 37, there is a difference in longitude of, when you subtract 42 and 37, you get 5 degrees. There is a difference of 5 degrees from 42 to 37, where Mandera is and where Nairobi is. So with 5 minutes, with 5 degrees difference, now we can say if 1 degree is 4 minutes, as we have seen in the comparison, then how many minutes will be represented by the 5 degree difference? This will be 4 by 5, giving us 20 minutes. Therefore, the difference in time between Nairobi and Mandera is 20 minutes. If it is 20 minutes, now we can now relate and say we are given the time in Mandera as 3 p.m. and we are asked to get the time in Nairobi, and we know that Nairobi is west of Mandera. So comparing Nairobi and Mandera, Nairobi is behind in time because it is in the west of Mandera. Therefore now, because Nairobi is behind in time for it being on the west, then we will subtract. Therefore, 3 p.m. less 20 minutes gives us 2:40 p.m. Therefore, Nairobi is 2:40 p.m. while Mandera is at 3 p.m. Therefore, time in Mandera is ahead because Nairobi is west, in the west of Mandera. It is behind in time. So that's how we calculate it. In case you find a case whereby you are being asked time in a different place, which is in the east of the given one, then in such a case, you add the time difference because places in the east are ahead in time. I'd like us to check something else called speed. Something called speed. We have already known how to calculate distance, and now we want to check speed on the Earth's surface. Mathematically, even from the primary school level, we know that speed is given by distance divided by the time taken. Divided by time taken. Therefore, it is not changing. We are still dwelling on the same concept that speed is given by distance divided by the time taken. Now, the most important thing here to be noted is that when speed is calculated in nautical miles per hour, it is called knots. It is called knots. So, if you are relating the nautical miles covered per hour, then such speed is said to be in knots. If you have covered 20 nautical miles in an hour, then we say the speed in this case is 20 knots. 20 knots. The other side now, the one we are used to. If distance has been calculated in kilometers per hour, then the speed is given as usual, kilometers per hour. Therefore, if distance is in nautical miles, then the speed will be calculated in knots. If distance in kilometers, then speed will be calculated in kilometers per hour. Let me give an example to help you understand this. You are told a ship leaves Mombasa. A ship leaves Mombasa. Mombasa is 4 degrees in the south, 39 degrees in the east, and sails due east, and sails due east, and sails for. A ship leaves Mombasa and sails for 98 hours to a place K, which is 4 degrees in the south, 80 degrees in the east. Like that, calculate its average speed. Calculate its average speed. 1 in kilometers per hour and 2 in knots. So we'll get speed in kilometers per hour and speed in knots. Let me start by sketching the positions of the 2 places on the Earth's surface. Solution. We have Mombasa, 4 degrees in the south and 39 in the east. Therefore, this is Mombasa. Then place K is 4 degrees in the south, so the same latitude, and 80 degrees in the east. 80 degrees in the east is where we get time K. So with that now, we can see that the 2 places are on the same latitude. Therefore, we are getting distance along a small circle in this case. First of all, in kilometers, so that we may get speed in kilometers per hour. Therefore, distance for small circles, we get it by alpha all over 360 to pi r cosine of the latitude where the 2 places are. Therefore, alpha is the difference in longitudes. K is 80, Mombasa is 39. Therefore, the difference in longitudes from 80 to 39, the difference in longitude is 41. Therefore, this will be 41 all over 360 to pi r 6370, which is the radius of the Earth, cos latitude. They are on latitude 4. Therefore, cos 4, because they are on latitude 4 degrees. 41 by 2 by 22 times 6370 cosine of 4. Then we divide by 360 times 7. This gives us 4,549 kilometers. So that is the distance from Mombasa to town K or to place K. Therefore, now with the distance, we can move to get speed in kilometers per hour. and it is distance all over the time taken. We are told this 45, 49. We divide by, the ship took 98 hours. Divide by 98, and we will get, when we divide by 98, we will get 46.42 kilometers per hour. Therefore, the speed in kilometers per hour will be 46.42 kilometers per hour. Now, part 2, in knots. To get speed in knots means we will get distance in nautical miles. Distance in nautical miles. For us to get distance in nautical miles, we know that it is gotten by alpha times 60 times cosine of the latitude, where the two places are. Therefore, it will be the difference in longitudes from 80 to 39, because we know how the two places are on the Earth's surface. We have already calculated. It is 41 times 60 cosine of the year on latitude 4. Distance in nautical miles will be 41 times 60 cosine of 4. This gives us 2,454 nautical miles. Now, to get the speed now, it will be again distance over time, but distance is now in nautical miles. Divide by the same time, 98. When you divide this by 98, we will get 25 knots. So in this case, we will not write nautical miles per hour. Speed in nautical miles per hour is expressed as knots. So that is what we call speed when it comes to this topic. In nautical miles per hour, we call it knots. For the other distance in kilometers, as usual, we express speed as kilometers per hour. Let me give now a summary of this topic, which is called longitudes and latitudes, before I handle the last question on the same. I'm going to summarize the topic as this. Let me give a summary of all the tips you've gone through. We know that the position of a place is given as a coordinate of the latitude and the longitudes in that order. That's how we give the position of a place. E.g., we can have town P as 48 degrees latitude north, then 50 degrees in the east. This is the latitude, this is the longitude, where town P is. Again, something which we should master ignorantly is distance along a great circle. Distance along a great circle. We should know that distance along a great circle is given by theta all over 360 2 pi r. This is in kilometers. And again, we should know that for this same circle, distance is given as theta times 60. This is for the case of nautical miles. Again, distance along a small circle. Similarly, we can have theta all over 360 2 pi r cosine of the latitude where the two places are. This is in kilometers. And we can have distance expressed as theta times 60 cosine of the latitude where the two places are. This is in nautical miles. In the same topic, we have mentioned something very important, and I'll mention it again. We have said that the shortest distance between two places on the Earth's surface is the distance along a great circle. So from where a place is to the poles, either the South Pole or the North Pole, then you add, you get the shortest distance compared to when you take the distance along a parallel latitude. So that's how we get the shortest distance. Again, on the same topic, we have said that now about time, that 1 degree is equal to 4 minutes. And on the same note, we have said that places on the east are ahead in time compared to places on the west. We have said that. So you find that to get time for places in the east, we add the time difference. On the contrary, for places in the west, to get time difference, we subtract, because places in the west are behind in time compared to places in the east. We had also mentioned something about speed, and we said that speed, when distance is in nautical miles, is calculated as knots. So we say speed is in knots when the time is in nautical miles. For kilometers, it is kilometers per hour. So this is a brief sum up of the basic tips in the topic longitudes and latitudes. Allow me climax the topic with one example, and we are going to solve it together. Therefore, make sure you remember all these tips as we do the example. So I'll read the example as I also write it on the board. Make sure you are following. That summary is very important. Keep it for your benefit. The question says, the position of 3 ports, A, B, and C are, the position of 3 ports A, B, and C are 34 degrees north, 16 degrees in the west. We have 34 degrees in the north, 24 degrees in the east, and 26 degrees in the south, 16 degrees in the west, respectively. Then you are told, find the distance in nautical miles. Part A, find the distance in nautical miles. Find the distance in nautical miles. Then We are told part A, ports A and B to the nearest nautical mile. Then Roman 2, we are told between port A and C, and part B of the question we are told a ship left port A on Monday 30 hours and sailed to be at 40 knots. That is speed. Calculate part 1 of this question. We are told to calculate the local time at B. The local time at B when the ship left A, when the ship was leaving A, the local time at B. Then Roman 2 of the same question, the day and time the ship arrived. The day and time the ship arrived in B or at B. So that is the question. That is the question. I would like us to solve it together. Then we'll be concluding. Solution. As usual, I will start by sketching the position of these 3 ports on the Earth's surface. If this is the globe with 0 prime meridian and 0 equator, we are going to have 34 degrees in the north, 34 degrees in the north, and 16 in the west. So 16 degrees in the west, where they intersect, we are getting port A. Then port B is the same latitude, but 24 in the east. 24 in the east. This is where we have B. Then port C is 26 in the south. So C is on the other side. 26 in the south. We've said this is 34 in the north. Therefore 26 and 16 in the west. Therefore C is here. C is on the same longitude with A, but A is on the same latitude with B. Therefore that's how the 3 places appear on the Earth's surface. So that sketch is very important. Now we go to the question. Find distance in nautical miles from port A to B. So from A to B, it is along a small circle, and we are finding distance in nautical miles. Therefore, part A, Roman 1, we know that distance is found by, when we take in nautical miles along a small circle, alpha times 60, because it is a small circle, cos latitude. Therefore, it will be alpha, the distance or the difference in longitudes between A and B. A is at 16 west, B is 24 in the east. Therefore, the difference, because they are on the opposite sides of the prime meridian, we are adding the longitudes. 16 plus 24 gives us 40. Therefore, it will be 40 by 60. Cosine of the latitude, where they are at 34 degrees. Therefore, when you compute this, you get, when you compute 40 by 60, cosine of 34, this lands us at 1989.69, but we have been told to the nearest nautical mile. Therefore, to the nearest nautical mile, this simplifies to. This one is greater than 5, therefore it increases this. You'll be getting 1990 nautical miles. That is the distance in nautical miles to the nearest nautical mile. Part B, the distance of ports A and C. From A and C, and also we are getting in nautical miles. A and C, it is distance along a longitude. A and C are the same longitude, and we are going to get distance in nautical miles along a longitude, which is gotten by theta times 60. So theta is the distance or the difference in the latitudes. This is latitude 34 and this is latitude 26. They are on the opposite sides of the equator. Therefore, to get the difference, we add 34 and 26. Therefore, the difference in longitude from C to A or from A to C is 34 plus 26. This gives us 60 by 60, which is a constant. This gives us 3600 nautical miles. So that's how we get the distances for part A, like that. Now, we have part B, and it has some instructions. We are told there is a ship which left A on Monday, 13:30 hours, and sailed to B at 40 knots. Calculate the local time at B when the ship left A. So, if at A, the time is 13:30, it is good to check this. I'm going now to solve it on this side. Part B. We have time at A, 13:30 hours. When we check where B is in the east of A. Therefore, time in A is already ahead, and we can get the difference in longitude. From A to B, the difference in longitude from 16 to 24 is 40. Therefore, difference in longitude is 40 degrees. Now, because we know 1 degree is equals to 4 minutes, the difference in time for the 40 degrees will be 4 by 40. And this gives us 160 minutes. 160 minutes is the same as 2 hours and 40 minutes. Therefore, the time difference between A and B is 2 hours 40 minutes. But we know that B is in the east of A. Because B is in the east side, then time in B is ahead by 2 hours 40 minutes. Therefore, the time in B will be 13:30 hours plus 2 hours 40 minutes. This gives us 10 carry 1 hour, 16 10 hours. So the time in B is 16:10 hours. 16:10 hours because B is in the east side compared to A, and for that a case, we add time difference. In case it was on the west, we could have subtracted. Now, lastly, we are told to find the day and the time when the ship arrived at B. It is good to note that we are already given the distance between A and B. We have already calculated it in part A as 1990 nautical miles, and we have been told that by this examiner that this ship is sailing at a speed of 40 knots, meaning then we can get the time it will take. So we can say for part 2, time taken is equals to distance all over speed. So we have distance as 1990 nautical miles and a speed of 40 knots. a speed of 40 knots. Therefore, this ship will take time which is equivalent to 49 hours 45 minutes. 49 hours 45 minutes. Therefore, this is the time taken by the ship to sail from A to B. Now we know that the time it was starting to sail at B, it was 16:10. We want to know the time it will arrive. Therefore, in 49 hours and 45 minutes, we have 2 complete days and 1 hour 45 minutes. Therefore, first of all, the 2 days will take us to Wednesday. Because it started on Monday, it will be Wednesday, and above the 2 complete days, we have 1 hour 45 minutes. So we will have 16:10 plus 1 hour 45 minutes. This becomes 55 minutes 17. Therefore, this ship arrives in this particular port called B at 17:55 hours, or you can call it 5:55 when you express in the 12-hour clock system. It will be 5:55 p.m. on Wednesday. Therefore, just taken 49 hours and 45 minutes, meaning that these are 2 complete days and an extra 1 hour and 45 minutes. That's why we are adding, first of all, the 2 complete days, so that they may land us on Wednesday. Then the extra 1 hour 45 minutes is added now independently, and we are getting 17:55 hours. So that is the time of arrival. Thank you very much for listening. That's all for the topic longitudes and latitudes. Welcome for the next subtopic. We are going to be together. May the Lord bless you.